Okay, it's recording. All right, so we are on DPS Math 6, Day 8. They have a video resource for us, which I admittedly have not viewed. And they do have some examples. Your child is learning about positive and negative numbers. Positive numbers are greater than 0, negative numbers are less than 0. Here are some real-world situations that involve positive and negative numbers. The outdoor temperature is recorded as the number of degrees above or below 0. So that would be a vertical number line. Where these would be your positives, and these would be your negatives. A bank account shows an amount of money deposited with a plus sign and the amount of money withdrawn with a minus sign. That's not always entirely true. Sometimes a withdraw is just in parentheses. So in Money World, sometimes negative $2.50 really looks like this. A daily change in a stock market index is reported as rising or falling a certain number of points. That's true. You've probably seen a lot of falling lately on the news. A positive number and a negative number that are the same distance from 0 are called opposites. We talked about opposites before. They reflect. Who do they reflect over? A little louder, because I think somebody said it. 0. Yeah, they reflect over 0. So this is where positive 3 is, and this is where negative 3 is. They reflect over 0. Excellent. Got an example here. Luis checks the temperature on the thermometer on 2 days in different months. One day the temperature was 10 degrees Celsius. Above 0. The second day temperature was the opposite of the temperature of the first day. So it was here. Right. So day 1 was a positive 10, which can be written like that or that. And day 2 is the negative 10. Perfect. So this is just a quick review of integers. That's what they're going over right now. All right, we did that. They went over it. Feel like we did it. Okay, but this is a horizontal number line. On a number line, a positive number tells how far above or to the right of 0 the number is. The negative number tells us how far below or to the left the number is. So over here you have your positives. Over here you have your negatives. So it's either going to be right and left or up and down depending on which way you go. They're just trying to show you that this vertical number line is equivalent to this horizontal number line and that it can represent the same things. If you have background noise or if you have a person you're chatting with, please mute yourself because we can hear your conversations. All right, friends. Number 1, calculator inactive. Do I have anybody who could read it for me? Loud and proud. Anybody? Okay, Thomas, go ahead. It might be helpful to put them in order from least to greatest. Okay. So, least to greatest. Let's see. Least to greatest in how much they owe? Or how did you do it? Because somebody said that's what I did. Like, least how much they owe. Which person? Say it again. Okay, so Jonah owes the least. So Jonah is at negative 2390. Then next would be Emma, yeah? At negative 2630. And then Maya has the greatest debt. Least debt, greatest debt. Maya owes $29.05. So Maya owes the least. Not true. Emma owes the most. Not true. Jonah owes more than Emma. False. Maya owes more than Jonah. Yes. Did everybody get D? Fantastic. Good job. Oh, coordinate grids. We haven't seen that in a little bit. Reminds me of Garfield. Okay, missing Garfield right now. Who wants to talk us through this one? Which point on the coordinate grid represents 5, negative 3? Talk us through it. Tell us like what you know about the grid. I had one hand and that person just went. Let's have somebody else. Is that you, Trenton? You want to go? Okay, talk us through it. Okay, are the things I'm highlighting relevant to what you said? Those of you having your personal conversations, please mute yourselves. Trenton, back to you. Is the 5 X or Y? Good. So negative 3 is the Y. So you went over 5 to the right. We can hear your private conversations. I'm gonna kick some people out here in a second. Excuse me. There we go. I'm only going to unmute Trenton because he's who I need right now. All right, Trenton. Can you hear me okay still? Fantastic. All right, so we go over to the right 5, and that represents X. And then after we do that, Trenton, what do we do? That is fantastic. So it appears our answer is here. So to recap what Trenton said, he goes, go to the right 5 to represent the positive 5, and then go down 3 to represent the negative Y coordinate. That would put us at point R, which is selection C. Is that what you got, Trenton? Fantabulous. Good job, Trenton. Oh, it looks like real math. Ah! Don't panic. Okay. Up next, we are on number 3, still calculator inactive. Do I have a volunteer for 3? Please raise your hand if you are going to volunteer for 3. Anybody? Anybody? Raise your hand using the icons because I can't see all your faces. There we go. All right, Malika, let me unmute you. Talk to us, Malika. Yes, ma'am. That is true. Okay, go ahead. Jimenez? What operation are you hearing? Yeah, so we gotta divide. So if I'm gonna make a division box, who's gonna go on the inside of the box and who's gonna go on the outside? Who's your dividend and who's your divisor? I agree. Your dividend is $39.90 and your divisor is 10. And now we just need to work it out. 10 goes into 39 how many times? Okay, 3 times 10 is 30. Gonna subtract and bring down. 10 goes into, notice I brought my decimal up in case you guys are following along. 10 goes into 99 how many times? 9. 9 times 10 is 90. I'm going to subtract, bring down, and now we have 10 going right into 90 how many times? How many times did 10 go into 90? 9. Perfect. So I'm going to complete that out. 9 times 10 is 90. We subtract. Voila. No remainder. So each watermelon is $3.99. It says to express the answer is dollars and cents. So to me that says we need to do 3.99. You could have aligned it to the right-hand side, but I aligned it to the left-hand side. Excellent job. Thank you. I have somebody who has their hand up and it just says guest. I don't know who it is, so I'm going to unmute you and talk to us. Oh, hi. I'm going to post this video. Yeah, I'm going to post this video. The thing about me posting this video, though, is I suspect it'll only pick up my voice and not y'all's voices. So you'll still see the problems being worked out, but you'll only hear half of the explanation because the students are explaining the other half. Okay. Uh-huh. Okay. All right. Moving right along to number 4. We got a volunteer? We do. Hi, Truman. Okay, Truman. How you been, friend? Good. All right, same directions as before with the mixed number, etc. thing that Malika already read aloud. Let's dive right into the problem. What's the problem, Truman? All right, I'm going to create a division box here. Who is my dividend and who is my divisor? That is perfect. Divisor is 12. Dividend is 1,476. All right, let's just walk right through it. Truman, in your work, where would you start? Say it in reverse. There you go. Okay, so how many times does 12 fit in? Once. All right, so we're going to do 1 times 12. We're going to subtract and bring down. Okay, now what? Good. 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 Keep going. I'm listening. Good. Got it. Yes. Correct. Excellent work. So 1,476 divided by 12 is 123. So you could align it in your box all the way to the left, all the way to the right. You tactically could put it smack dab in the middle, but I try to keep it to an edge. I'm going to put mine right there. I'm going to align it to the right. Excellent work, Truman. Thank you for participating. All right, we are on number 5. Still calculator inactive. Ooh, it's got a decimal. All right, who is feeling ambitious with the decimal? I did a bunch of decimal work like the other day. A ton. You should be super awesome at this. If you want to do this problem with me, put your hand up in the reactions or the icons, because I can't see all your faces right now when I screen share. I need a volunteer. There we go. Hi, Josh. Okay, Josh, what do we got? You had your hand up. We're on problem 5. Okay, read the problem for me. Fantastic. Keep going. Okay, I'm gonna pick on you for just a second. Let's say it in the correct mathematical terms. 164 and 4. Good. Divided by 2 and. There you go. All right, so I'm going to create a division box here. Who do you want me to put on the outside of the box, Joshua? Yes. So that is your divisor, making the other one your dividend. We're going to find the quotient in just a minute. So Joshua, as I'm looking at this problem, I run into an issue. What is my issue? What's the problem happening before I can start? Okay. I need this guy to be a whole number. The divisor needs to be a whole number, so what do I have to do with the decimal? Yep, I need to move it one place value. Excellent, Josh. So if I move this one place value, to be fair, I have to do what over here? That is correct. And I'm going to put my decimal in my quotient right away before I forget about it. Now, we're going to walk through the division. I'm going to help you a little bit in the beginning here. 24 can't go into 1, and 24 can't go into 16. We got to figure out how many times 24 goes into 164. Did you make any educated guesses yet? I'm gonna see if I have some scrap paper too. What do you think? How many times? You can make a guess. It's fine. How many times? 7? 7 might be too generous, but I'll test it for you. 24 times 7. Only slightly generous, right? Because 7 times 4 is 28. Put down 8, carry 2. 7 times 2 is 14. 14 plus 2 is 16. That exceeds it. So we obviously have to go to which number, Joshua? Six. Good. Let me work that out. 6 times 4 is 24. Put down your 4. Carry your 2. 6 times 2 is 12. Plus 2 is 14. So we got 144. My 6 is going to go directly above the 4 in the 164. Line up your place values accordingly. 6 times 24, I already did the scratch work on my scratch paper, is 144. What is the very next step, Joshua? Okay, what am I going to get? 164 subtract 144. Perfect. Yes. Smart. So now I've got 24 going into 204. What educated guess do you want to do there? Yeah, I'm thinking it's either 8 or 9. Do you mind if I test 9 first? It's okay. Just curious. 18, 19, 20, 21. Nope, didn't work. So you probably write it 8. 2, 3, 16, 17, 18, 19. So you were right with 8. Good job. 8 times 24, I got 192. Did anybody else get 192? Anybody? Okay. Let's do 204 subtract 192. What is 204 subtract 192, Joshua? It is 12. Good job. I need to put a 0 here because I still have a remainder. I still got to bring something down. So now I've got 120 sitting there. Make an educated guess. How many times can 24 go into 120? Okay, we can test 5. So 5 times 4 is 20. Put down your 0, carry your 2. 5 times 2 is 10. 10 plus 2 is 12. That gets us exactly 120. So we're going to put a 5 here. I'm going to finish this off for you. I've got no remainder left and nothing left to bring down. I've got trusty calculator here to check our work. 164 and 4/10 divided by 2 and 4/10. You got it right. Good job, Joshua. So we got to put this in the box. So good. I think it fits. Nice. Okay, friends, we're moving right along. We're more than halfway done. Oh yeah, we're more than halfway done. Fantastic. Number 6. Martin. Welcome, Martin. Go ahead, friend. Okay, now just from the language, what unit does this remind you of? Yep, okay. Least common multiples. So the factors of multiples unit. Ari Waters is done every 3 days and Weeds it every Saturday. Did you draw a diagram? How'd you handle it? Okay. Did you do list form like horizontal or table form more like vertical? Okay. So did you just skip count by 3? So we got 3, 6, 9, 12, 15, 18, 21. And then 7, 7, 14, 21. Did you go beyond that? Okay, so who was your least common multiple? 21 days. I agree. Fantastic. Looks good. I could see this tripping people up on the whole Saturday thing. And if somebody does get tripped up on the whole Saturday thing, you could just draw like a diagram to help you. A picture could always help unravel the mystery of the language. Good job, Martin. Thank you. Okay, let's see. And that one was calculator active. I didn't even need my calculator for that one. How bizarre. I always give you the calculator when you don't need it. Ooh, fractions. All right. I saw Truman had his hand up a second ago. Truman, I lost you. Let me see if I can find you again. There you are. Did you have a concern, Truman? I think you might be overanalyzing it. Because I think it is fair to say that if it happens every Saturday, it happens every 7 days. Martin wants to chime in. Go ahead, Martin. It does. You're right. Second sentence. That's fair. No, it's no problem. I'm glad we cleared that up. Good deal. Nice discussion. Okay, we are on 7. I need a volunteer for 7. Just put your icon up. There we go. We got Maddie. Hi, Maddie. Let's do it. 7. Woo. Maddie, did you draw a picture? I want to draw a picture real bad. Did you draw a picture? Let's do it. I want to draw a picture. Okay, so the entire trail is 3/4 mile long. So that would be in my world. And if you'd like to join us drawing a picture, I think it is helpful. The trail is my highlighted yellow. But now we have to have a sign. What is interesting is they said they want to put a sign at the beginning and the end. So I've got a sign here and a sign here, in addition to all the signs in between. So it's a minimum of 2 signs no matter what you do. Now where do we go? Oh, I'm sorry. So we have a minimum of 2 signs because the problem stated that we have to have a sign at the beginning and a sign at the end. Now we have to figure out where the signs in the middle live. How are we going to do that? And if you don't know, that's fine. Somebody else can raise their hand and chime in. How do we do that? How do we do that? I got lots of hands popping up everywhere. All right, Thomas, what are your thoughts? Okay, let me hear from Joshua as well. Joshua, talk to us. You want to count by 5s? 5s aren't feeling natural to me when I see the particular numbers we have. Let me hear from Aaliyah, but good contribution, Joshua. Thank you. Aaliyah, what are you thinking? I think you're on a good road there, and I think I'm going to hear from Martin and then probably go down your road. Let's see. Oh no, I got more people popping up. I lost Martin somewhere. Let me go with Juvia. I see your hand up. Go ahead, Juvia. Well, I think that goes off of like what Leo was saying. I mean, we've got 3/4 a mile total, and we've got to divide it by 1/12. So, what is the easiest method we learned? What is the easiest method? Yeah, I would absolutely go with common denominator. We already have 12, and 4 and 12 are friendly. So I'm going to turn this guy into a 12. That was 4 times 3. So 3 times 3 will get us 9, 12. So now I have an equivalent fraction. What's great about common denominators is what is the very next step? Juvia, what's the very next step? Okay, so now I've got 9 divided by 1, which is just 9, and 12 divided by 12, which is 1, which means there would be 9. Interesting. So I need to talk this out, because it says it needs 9 signs, but we had one at the beginning and one at the end. Let's problem solve that, because right now, if we did 9 plus 2, the answer would be 11, and there is no 11. Let's hear from Martin. What are your thoughts, Martin? Okay. I totally agree with you. That was my thoughts exactly. This one is included in this number, yes? But this guy wasn't included. So it's 9 plus the starter sign. So you've got 10 signs total. Voila. And they gave us a calculator active. I don't have one of our cool blue calculators at home. It's like the one thing I forgot to bring home from the classroom. But if you do have your cool blue calculator, type it in. It's easy to do fractions on your calculator, not on mine. And make sure that 3/4 divided by 1/12 is in fact 9. Let me hear from Aaliyah. Aaliyah, did you get 9 when you did that? Okay. All right. Just so you guys know, I unmuted all of you. So if you're talking privately, mute yourself. $1.12. Perfect. So that includes all the signs after 0 all the way up to the last sign, and then if we add one more beginner sign, that is 10. Perfect work. All right, moving right along. I muted all, but I gave you the ability to unmute yourself when I call on you. Which situation is unlikely to be represented with a negative value? Again, they let us use a calculator, and yet there are no numbers. Okay, who wants to go over this one with us? I've heard a lot from the same people. Anybody new want to talk to me? Anybody new? I see lots of friends in the room. Come on, peeps. I'm going to pick on somebody. I am. I'm going to pick on somebody if somebody else doesn't volunteer. All right. The person I am picking on is Ella. Ella, can you unmute yourself? Maybe not. Give me a thumbs up, a visual thumbs up, if you guys can still hear me. Okay, Trenton, Zaya, they can all still hear me. Okay. Trenton, do you want to go through this one since I know for sure you can hear me? Or Zaya, do you want to go through this one since you can hear me? Unmute yourself and talk to me. Zaya's like, no, a big no, big N to the O. But Trenton, are you with me? No. All right. Martin, go ahead if you can unmute yourself. For some reason, my screen is frozen. I totally agree with you. The rest could go kind of either way. A change in temperature could go up or down. The distance from sea level could be above sea with a bird or below sea with a submarine. This week's race compared to last week's race, we have no idea what happened, so we could go up or down. But if you're putting money into your account, I hope money's going up, because that's really what we're hoping for when we put money into the account. Excellent job, Martin. That selection is B. Now, part of my Zoom has completely frozen on me. So if somebody would like to volunteer for 9, just unmute yourself and speak up, because I can't unfreeze my Zoom right now. Who wants to do 9? Just speak on up. That's a lot of volunteers. 25 people in the room and nobody's talking. That never happens in the classroom. Somebody unmuted themselves. Does that someone want to go? Hey, Sky, will you do 9? I'll help you. Ooh. Okay. Okay, when they get complicated like this, if it helps, we can put some real numbers in there. Yeah, yeah, because this is like, probably sounds like Latin right now, right? Okay, let's just test it. If P and Q are negative integers, and we made P, let's just make it -1, and Q -2, that would be like -1 plus 2. That would be positive. But I'm going to switch those. What if it was -2 minus -1? Then I would be like -1. So they're saying if both of them are negative, it will always be negative. Well, I already disproved that. It's not always going to be negative, because I proved it could be positive. I'm thinking we should cross off A. Does anybody else want to interject on that? Okay. Read me the second one, Sky. I feel like this entire part of the sentence is like extraneous. Okay, they want P to be negative and Q to be positive. I feel like we're going to get more negative, because that would be -1 plus -2, so you're going to be -3. Now let's try it. If P is negative, let's have P have a greater absolute value. Let's say P is -2 and Q is 1. and I subtract, I'm still going to get negative 3. Will it always be negative? It's starting to look good. It doesn't look bad from my couple examples. Let's keep going. Okay, I did a positive 2 and a positive 3, but 2 minus 3 is negative 1. But if I swap the values and it's 3 minus 2, it's a positive 1. So it will not always be positive. So that can't be. Let's try D, and then let's hope that B was the right choice. They give you a lot of language there. P is positive, and Q is negative. Okay, we can try this one. And then if I do that, that's like adding the opposite. That becomes positive, and they said it will always be negative. I already disproved it in my first example. I don't even have to go to a second example. So, of our choices, B is the best. How does everybody feel about that? Can you give me a thumbs up, thumbs down, flappy? Let me see. Let me look at your beautiful faces. Let me see if I can see people. Okay, I see a lot of people who think that that is good. I appreciate that. Thank you. Oh, and we got people clapping. One more, we're done. That's super exciting. At least it is to me. Who wants to do 10? Just unmute yourself because my Zoom menu is, in fact, frozen. Okay. Whew. Okay. 25 and 75. You read like at lightning speed. I could not keep up. The third number is GCF of 27 and 36. Well, this is super convenient because we just did a bunch of interactive notebook pages on GCF. Greatest common factors, the biggest number that goes into each of them. At first glance, this one's the easiest one for me. I mean, I can do that one in my head. What is that one? The biggest number that goes into both of these? $25. Let's hear from Malika. What do you think is the biggest number that goes into 25 and 75? There's like roosters in the background. That must be Juvia. Sorry, Malika. Hold on, Juvia. All right, Malika, what'd you tell me? I agree. I think it's 25. If we do agree that that is 25, we can already eliminate 2 of the choices off the list. All right, now the biggest number that can go into, I like this one next. This one, to me, is the second easiest. But that's because I know my multiplication tables really well. What's the biggest number that's going to go into 27 and 36? 9. So that eliminates that guy. And then I'm going to double check and make sure 8 goes into 16 and 8 goes into 40. And yeah, it does. So we're done. Hallelujah. It only took us 47 minutes. Yeah. Woohoo. So the only thing you have left at this point are your interactive notebook pages, which will be graded. I'm going to take me off a screen share so I can talk to you guys about what I learned yesterday. I am going to stop the recording if I can.